All right, welcome to the Chapter 4 and 5 practice test for Intro to Stats. So we're going to fill in this probability distribution here. And this is the discrete random variables. So the discrete random variable is the number of heads that show up. So we're going to flip a coin 3 times. So it could be heads, 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 tails, heads, tails, heads, tails, heads, heads. Okay, so I got or 3 heads, 2, and now I have to go to 1. So it'd be heads, tails, 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 heads, tails, and tails, tails, heads. And then of course 1, 2, 3 tails. So that's the complete sample space for this situation. So there are 3 heads, so x is the number of heads, so that happens 1 time out of 1, 2, 3, 4, 5, 6, 7, 8, so that's 1/8. And then 2 heads happens here through there, so it'd be 3 times, 3/8. And then 1 head happens there, that's 3/8. And then no heads would be 1/8. Now it's a sample space, and the sample space is 8. The distribution is 1/8, 3/8, 3/8, 1/8. If you add those all together, you get 1. You get 8/8, which is the whole point. Your probability distributions add up to 1. Your probabilities are distributed over 1. So all the fractions must add up, all the decimals must add up to 1. This is a discrete random variable because there's no numbers in between. It's either you get a head or you don't get a head, right? And you get 1 of them or 2 of them or 3 of them, right? There's no decimals in between. All right, so this has to add up to 1. So we just look at this and we say, hey, how does this add up to 1? We get 0.25 plus 0.60 plus 0.1. That's 95%, or 0.95, so that means 5% is missing. 0.05, that's it. Okay, then the formula for this, I'm going to pause it here for a second, find my formula sheet. Okay, for a generic discrete random variable, this is the formula for expected value, or mu, and this is the formula for standard deviation. So this is not a binomial distribution. This is just a distribution that I kept track of. So we do the first column, you got to do x times p. So you do this times this, which is 0, this times this, which is 1.0, and then this times this is 0.28, and that times that is 0. Okay, so we do the sum of x p of x. That's what mu is equal to. That's what it says here on the formula sheet. So we add this up. Oh, I messed up. It's 1 times 0.5 is 0.5. My bad. I don't know. I guess I crossed right there accident. So 0 times this is 0. 1 times this. I must have crossed over because I'm trying to go through this quickly. So this times this is this. This times this is this. This times this is this. This times that is that. You add this column up because that's the sum of x p of x. So when you add that column up, you get 50 cents and 28 cents. So mu is 0.78. All right. Then for the next one, you have to sum up x minus mu squared p of x. You sum that up, and then you take the square root. That is your standard deviation. So the first thing you have to do is you have to do x minus mu squared p of x. Okay. Well, we know that this answer down here is 0 because p of x is 0. So now we're going to do the other one. All right, so it's x, which is 0, minus mu, which is 0.78, quantity squared, times the probability, which is 0.36. Enter. And it looks like I kept track of all these decimals. 219024. Okay, and we go up arrow, copy paste. So then we're going to do the next one, x, which is 1, minus mu, which is the same, times the probability, which is 0.5. Okay, 0242. Okay, then we go up arrow, enter, and now it's going to be 2 minus mu squared times the probability, which is 1/4. Okay, so I get 0.208376. Okay, so I'm not doing the last one because you're doing times p of x. The probability of this was 0. So it's really just these three numbers. So the formula, again, is to add up those numbers, take the square root. Well, since I have the copy-paste feature here on the calculator, there's my first answer, enter, plus the second answer, enter, plus the third answer, I want to hit plus first, plus the third answer. All right, so that's the sum of it. So the sum of this column is 0.4516. All right, then I'm going to take the square root of that. So it's the square root of 0.4516. That's going to be my standard deviation. And so I hit second and then 0.5 because that's the same thing as square root. And 0.672. Alrighty, that's the first page. Then we go into the binomial distribution. So there are 40 questions on this test. So n is equal to 40. All right, you're just guessing blindly on this multiple choice test. There's 4 choices. So the probability of success is 1/4, which is the same thing as 0.25, right? The probability of failing to get it right is 3/4 or 0.75. So those are the important things that you need to do. Okay? So I identified n, p, and q, and then calculate the mean and standard deviation. So the mu this is for binomial distribution is n times p is your expected value, and then n, p, and q square root is your standard deviation. So we just do n, which is 40, times success rate. 1/4 would be 10. Okay, well that makes sense because if you blindly guess, you're going to get 10 right. Hopefully, if you just blindly guess, you get 10 right, 25% right. Okay, so standard deviation is the square root of 40 times 0.25 times 0.75. That's n, p, and q. Take the square root. So we type that into the calculator. Second square root. 40 times 0.25 times by 0.75 is approximately equal to 2.73974, something like that. All right. So this is a binomial problem. The probability of success of winning the game is 59.2% or 0.592. And we want to do the next 5 games. So what are the chances of going 0 for 5 in the next 5 games? 1 for 5, 2 for 5, 3 for 5, 4 for 5, 5 for 5. So that would be the distribution over that time. So we go to second distribution. And we're doing the individual ones, so we choose the P. We're not doing the cumulative, so we're doing the P, the individual ones, so we choose that. And you can see I did this problem earlier today. So it's 5, right? There's 5 trials. I'm going to play 5 games in a row. That's my winning percentage, 0.592. And no wins out of the next 5. That's what that means. And we hit enter. 0, 1, 1. Okay, Then I go up arrow, enter. Now I'm going to do 1 win out of 5. So I change that. So that stays the same, just change it to 1. 082. Okay, then I'm going to go up arrow, change that to a 2. 238. Up arrow, change it to a 3. 345. Up arrow, enter. Change that to a 4. 251. Change it to a 5. 073. Boom. So that's the distribution. You add all that up, it's going to be really super close to 1, but I rounded, so it's not going to be 100% on 1. Okay, so then the expected value is what I did up here. It's the number of things times the probability. So it's just going to be number of games that play times by 0.592, enter, 296. So mu is equal to 2.96. Now, my winning percentage for 5,000 games is that. So 5,000 games is a lot of games. So that's kind of where I'm stuck. I'm winning about 60% of the time. So am I going to be able to raise my average from around 59-60% up to 65% over the next 1,000 games? I'm not going to be able to do that. It's just impossible because I'm fighting this average, right? I'm fighting this average. So the law of large numbers says that I am stuck there because I've played so many games. That's how many I win, about 59-60% of the time. So to be able to raise it up to 65%, I'd have to win way more than my average. And I'm not going to win way more than my average. I'm going to win around my average. So that's the whole law of large numbers situation. Okay, next question. This is the binomial distribution, and we have 30% say they're ready for the earthquake. We have 11 that we're going to go out and talk to. What's the probability? Exactly 4. Okay. Adequate earthquake supplies. I stole this question from somewhere. So we go to second distribution, up arrow, and I'm doing the P one because I want to know exactly 4. So it's going to be, I'm going to go out and talk to 11 people, and 30% is 0.3, and I want to find exactly 4 out of 11. Paste, enter. So 22%. The next one is the probability of success is 37%. There's 12 games, and I want to win 5 or more. So the probability that x is greater than 5 is equal to, now the calculator won't do above 5. It won't do 5 or more. It'll only do 4 or less. So I'm going to do 1. I'm going to do calculate the complement, right? And then subtract it from 1. So that's what I'm going to do. Okay, so we go to 1 minus, and then I'm going to go to second distribution. This time I'm going to use the C1 because it's cumulative, and it's 12 games, and I'm going to probability of success winning the game is 37%, and 4. So I'm doing 4 or less. Paste. So it's 1 minus that answer. See, I put the 1 minus first. Boom. Okay, let's say you forgot. Let's say you forgot to put the 1 minus first. Like you did this first. Then you just have to do 1 minus the last answer. Okay, so the answer is 475. Okay, 7 or fewer is okay. Probability of x is 7 or fewer. Okay, that's that one. We don't have to do anything fancy to it. 55% success rate of people going to their graduation, 5-year reunion. So we go to second distribution, up arrow, use the C one again, and we're going to talk to how many people? 20 people, group of 20, and success is 0.55, and we want to do 7 or fewer, and paste. So 5% chance, 0.058. All right, so area under the curve, so this goes into chapter 5, these last two questions. The area under the curve is represents probability. So basically your area is from 0 to 5. So 1, 2, 3, 4, 5. So it's 5 wide, right? It's 5 wide, and it is, the height is 1/5. So that times that is equal to 1. So the area is 1. So there's 1, 2, 3, 4, 5 parts, right? Well, I just want 2 parts out of the 5. So the probability of hitting there is 2/5, or 40%. Down here, the area has to be 1. So all of this area has to be 1. So if I go from 1 to some number, we'll call it x. So x minus 2 times a quarter has to be an area of 1. So how far do you go over? Well, you can algebraically solve it, or you can just think about it. What does this need to be? Well, this needs to be 6. 6 minus 2 is 4. 1/4 of 4, right, gives me 1. So it has to be 6. And that's it.